Okay, for this review problem, we have this function, f of x, is equal to the expected value of n minus x squared. Okay, let's simplify this and see what happens. We have the expected value of n squared minus 2 times x times n plus x squared. And so this splits up as the expected value of n squared minus 2 times x times expected value of n plus x squared. Okay, now the expected value of n, of course, is simply the mean. And the expected value of n squared is equal to sigma squared plus mu squared, because the variance is equal to the expected value of n squared minus the mean squared. So rewriting this, bringing this over to the left-hand side, we find the expected value of n squared is mu squared plus sigma squared. Okay, so that's the function f of x. Find the value of x that minimizes this function. Now, if you'll notice that if we're trying to solve for the value of x where mu and sigma are constants, this is basically a parabola. X squared minus something times x plus a constant. So that is a parabola. It is a parabola with a positive value of a, 1x squared. And so that means that when at the vertex of this parabola will be the minimum value. Now to find this minimum value, we'll take the derivative. And so we get minus 2 mu plus 2x and set the derivative equal to 0. And so that means the minimum value occurs when x is equal to mu. Then the smallest value is going to be f of mu. If I plug in mu into this, I get, everywhere I see an x and replace by mu, I get mu squared plus sigma squared minus 2 times mu plus mu squared. So I get mu squared plus mu squared minus 2 mu squared, and so I get sigma squared. And so this function is minimized when x is equal to mu, and the smallest value is equal to sigma squared. Now, this is another way of saying the following fact, which we already know, that the expected value of n minus mu squared, by definition, that is the variance of the random variable n, sigma squared. So, this expression here very much looks like the formula that's used to define a variance or a standard deviation, and the value of x that actually makes this the smallest possible is equal to mu.